So I have Aishu with me here, and we're going to go over two problems that I gave in the first week of homework and that she found a little bit confusing. So the first one was this x over 5 minus 3 is equal to 7. Hi, Aishu.
Hi.
Okay, she's with me here, so she's going to ask questions in case I'm confusing in any way. So the first step is, as before, get rid of any added or subtracted. And so the first thing is this negative 3 that's here. You want to add the plus 3 to both sides, and you get x over 5 plus 0. It just drops down. The minus 3 and plus 3 cancel, and you get 0. And 7 plus 3 is 10. So you're left with x over 5 is 10. So here we are again, x over 5 is 10. Now you get rid of any multiplied or divided. The 5 is being divided. What's the opposite of division?
Multiplication.
Multiplication. And so we just multiply both sides by 5. And what happens, this was good. I'm glad Aishu is here because I've done this several times, slashing out. So what's happening here is that 5 divided by 5 is really 1. And 1 times anything is itself. So in higher level math, we call this canceling. You're not doing that in your class yet, but you will. And it makes the math notation a lot easier if you do it this way. So whenever you have a number divided by the same number, you slash them. And it's pretty fun to do. You don't want to get too slash happy though, because sometimes that can lead to a mistake. But the point is that 5 divided by 5 is really 1. So I can slash them out and replace them with a 1. And on this side, 10 times 5 is?
50.
50. So that leaves me with x is 50. And you should check your work. Aishu told me she checked her work on Wolfram Alpha. You did? Okay. So is that one clear? Why was this problem confusing, you think?
I didn't really think it was confusing. I think it was this part where it said minus 3. I didn't understand it was negative 3, and I just thought of it as 3, so I thought adding 3 would make it 6.
Okay. Is it clear now?
Yes.
All right. So this one I mentioned was tricky, and it was. The first suggestion I had is we as human beings like to see the same thing all the time. And so we like to see our letters on the left because the first few problems were on the left. And so my suggestion to you is put them on the left and put the 10 on the right, right? So that it looks the way we're used to it. I think it might be time for a math joke at the end of this. So indulge me at the end of this. But right now, I'm just making it look the way that I'm used to. The second thing is to gather like terms. So this was on the little module about gathering like terms. So you see an n here and an n here. We don't write the 1, but there really is a 1 in front of n. So it's really 1 times n. Are you used to seeing the dot as times? Mm-hmm. Okay, 1 times n. And I have a 1/2 here. It doesn't look like a 1/2. But dividing by 2 is the same thing as multiplying by a half. Do you agree?
Yes, but how did we get the 1? How do we know n is 1?
The 1 times n? That comes from this n.
Yeah. No, I mean on top of the 1/2. The 1.
Well, whenever I divide by 2, like what's 4 divided by 2?
2.
What's 1/2 times 4?
1 times 4, 8.
1/2 times 4? What's half of 4?
2.
2. So dividing 4 by 2 is the same thing as multiplying 4 by 1/2. Do you agree?
Yeah.
Okay. So dividing n by 2 is the same thing as multiplying n by a half. So that's where the 1 comes from. It's a half is the same thing as dividing by 2. If you slice something by 2, if you take a cake and divide it by 2, you're really taking the cake and taking out halvesies. You agree?
Does that mean n is 1?
No. Yeah, it means that n is 1. So it allows me to really gather those like terms. So 1n minus a half n is a half n. Because if I have a whole n and I take away a half of an n, I've only got half left. Right? Because 1 minus a half is a half. So I can see that when I pull that 2 away from the n like that as a half. You can do that with any fraction. What do you think we would have if it was n divided by 3?
Then,
If I had, instead of n divided by 2 here, if I had n divided by 3, what fraction would I multiply n by? here I had n divided by 2 and it became a half. If it was n divided by 3, what would it be in here?
A third.
That's right. And that's a really important thing. You'll need it in calculus, actually. So it's it's weird. And it weirds people out in calculus too. But I use it all the time, actually. And so it's an important thing to think about, okay? Maybe we'll do a little session on just that, right? But you're going to believe me now? Okay, so now where I'm at is I have 7 plus a half n is 10. Agree? Mm-hmm. Now I have to get rid of anything that's added or subtracted. It may not look like it, but this 7 is being added because it's really plus 7 plus 1/2 n. So what's the opposite of plus 7?
Minus 7.
So it's the same old, same old. I put a minus 7 on both sides, and I get 1/2 n is equal to 3. So here I